All right, let's moving on to the name and the formula of transition metal. Now, the compound with transition metal. The transition metal are these metal in the middle of the periodic table. All right. For this course, we're gonna go up to zinc 30. So scandium, titanium, vanadium, all the way to zinc. You're gonna see this guy very often. All right. Plus the rest you have seen it before: silver, gold, and mercury. These are like you will see very often. All right. So for transition metal for this course, we're gonna go up to 30 zinc. Okay. All right. Why do we call them transition metal? Because their oxidation number changes easily and very often. Okay. I'll give you some examples. So iron and copper. Let's take a look. Iron with the oxidation number of 2 plus. So we got iron 2. The solution of iron 2 is green. The solution of iron 3 is red. Depends on the concentration. If it's dilute, it's going to be brown. If it's concentrated, it's going to be red. Copper 1, the solution is light blue. The copper 2 is dark blue. You know? That's why we call transition metal. They can have multiple oxidation number. And to name them, super simple. This is very easy. We use a Roman number to indicate the charge. For example, iron parentheses 2 Roman number. It tells you that's this is iron is +2. Space and chloride, same thing. We separate cation and anion. Right? The 2 right here, the oxidation number is right with the cation because it's the oxidation number of cation. Okay. Now you can guess now. So FeCl3, we're gonna call it iron 3 chloride. So use the Roman number with the parentheses. Okay. Space right here. All right. I'm sure you can guess the rest, right? So we have copper, we have sulfate. So this copper, this is 1, right? +1. So we go copper 1 sulfate and copper 2 sulfate. That's it. Okay. This is the new system that we just use the Roman number. That's it. All right. The old term, just for your reference. All right. If you heard this, people say this. Iron 3 plus, which is a regular, a common oxidation number of iron. We call this iron a ferric. If you still remember, Fe comes from ferrum, which is Latin mean iron. Right. So iron 3 we call ferric. So ferric chloride. The iron 2 plus we call it ferrous chloride. Right, we have it, we have us. Down here, copper 2 plus, which is the regular oxidation number of copper, we call it cupric. It's come from cuprum, right? Cupric sulfate. Guess what? Copper 1, cuprous sulfate. Yeah, that's a trend. Now, if you know the trend, things easy, things simple. So, all right, so iron 3, ferric. So lower oxidation number by 1, we call ferrous. Copper 2, cupric. Copper 1, lower oxidation number Y1, cuprous. I'll have you guess. Chromium, right? Cr3 plus, chromic. Cr2 plus, lower oxidation number by 1, what do we call it? Chromous. Okay? So, cobalt, we go cobaltic. Okay? CO2 plus, we go cobaltous. Yeah, there we go. Tin, is it tin, right? Sn stands for stanium. So we call stanium. Sn4 plus, which is a regular oxidation number. I don't know what I'm thinking. So oxidation number of tin. So we call stannic. Right, so it comes from stanium. So we call stannic. And Sn2 plus, we call stannous. All right. Now, there are only 2 transition metal that always have 1 oxidation number. Okay. The rest of transition metal have multiple oxidation number. They're much more than that, not just, but these are the main ones. Iron 2 plus, iron 3, manganese 2, manganese 3, right? But there are only 2 transition states that always have 1 oxidation number: zinc and silver. Zinc 2 plus, silver plus, always, right? Memorize that. I'm sorry, but you have to, because there's no way you know this. You have to memorize this. A part of all transition states, zinc and silver. Zinc always +2 and silver always +1. Remember that. Okay? All right, now, name. All right, we do name now. So same thing. This is ionic compound. So we cross over the transitions, the oxidation number. So for example, iron 3 oxide. So iron +3, oxide -2. So cross it over. That's it. Can you do the rest? Right, let's do the rest and then check with me. Okay, so iron 2 sulfide. So iron 2 is iron 2 plus sulfide, which is sulfur, not sulfate. This is not sulfate, so watch out. Right, sulfide group 6, so -2, right below oxygen. They already balanced out, so we just write Fe and S. Okay. All right, now next one. So we have manganese, we have oxygen. This is an oxide, right? It become in the compound. So what's the to write? You have to write the name here. Okay. Manganese is a transition metal. When you write the name, you're gonna need the Roman number here to indicate the oxidation state. Okay. Now, what's the oxidation state or oxidation number of this manganese? You can guess from oxygen right here, right? Oxygen group 6, so -2. There are 2 oxygen, which means that the whole molecule, they are -4 total, right? Each oxygen is -2, 2 of them -4. That's it. That makes manganese +4 because they have to be neutral, right? So we just call this guy, the name is going to be manganese 4 oxide. That's it. All right, let's try nickel. If you want to try one more time before we go further, all right, pause the video and guess nickel hydroxide here. Okay, all right. If you know so nickel is one of the transition metal. Okay, so when you write the name, you're gonna need the Roman number here. All right, so we have to find the transition oxidation number. We call transition state. Yeah, the oxidation number of nickel. To do that, you have to derive from hydroxide. So hydroxide is -1. The whole thing OH -1. There are 2 hydroxide, right? So the whole thing is -2. The whole anion is -2. Nickel have to balance out by becoming a +2. Okay, so we got nickel 2 hydroxide. That not that hard. Now silver nitrate. Okay, what's the formula of silver nitrate? So silver is always +1. Remember that? All right, silver is always +1. Nitrate -1. They already cancel out. So we just write AgNO3. Now next one, zinc. Oxidation number of zinc +2. Right, you have to memorize that. Silver +1, zinc +2. Oxide group 6, oxygen. So -2. They already they cancel out. So just Zn and O. Okay. Question to you real quick before we go further. So, how come silver and zinc they are one of the transition metals, right? But in this name, you can say the name. I didn't put the Roman number to indicate its oxidation number. Silver, I don't have to do 1 right here. Zinc 2 right here. How come though? Well, they have just 1 transition number. The oxidation number. So you don't need to write to indicate the Roman number here. Silver gonna always be +1. Zinc will always be +2. So not like iron. Iron can be +3, can be iron 2. Manganese could be 3, 2, 4, 5, 6, 7. There could be a lot of manganese. That's why you have to indicate it, the oxidation number. Okay. All right. So we quite have a lot of you for practice here. Same drill. You either write, hold on, go back. Okay. You either write the name, right? Like write the name or the formula. Make sure you get the right formula too, right? The one that are transition metal, so copper right here, you have to, don't forget the Roman number to indicate its transition state, okay? I say transition state, yeah, oxidation state or oxidation number. All right, and at the bottom, so we have A, B, C, D, E, F, G. The G, just give me 1 sulfate compound, 1 compound that have nitrate in it, 1 compound that have carbonate in it, and 1 compound that have phosphate in it. That's it. Okay. All right, that's pretty much it. Let's go to the next video.